Ever feel like the apps you use are juggling like a million things at once?
Yeah.
Well, that's what we're diving into today.
Yeah.
How's it actually happening and why Java is about to make it a whole lot smoother? We're talking Java virtual threads,
Yeah.
a game changer for concurrency in software.
It's not just hype. This is like fundamentally changing how we can build and scale software.
Right.
Especially for those server farms.
Yeah.
Handling the massive amounts of data we generate every day.
So our main source is a presentation by Ron Pressler,
Okay.
lead developer on this whole project over at Oracle.
Mm-hmm.
He talks about this concurrency crunch.
Yeah.
And I have to admit, the way he describes it, it kind of clicked for me.
Yeah.
It's like this, imagine you're building an app and every single task,
Mm-hmm.
every little user interaction needs its own like dedicated thread to run on.
It's like each of those tasks is a car on the highway.
Okay.
And each car needs its own lane.
Okay.
Works fine
Yeah.
when the highway's empty. But we all know what rush hour looks like.
Exactly. That's the problem developers have been facing. Operating systems just weren't designed for that level of like thread management
Yeah.
at the scale we need today.
Right.
It's inefficient,
Mm-hmm.
and at a certain point, it just doesn't scale.
This is where Little's Law comes in,
Okay.
which, and bear with me here, is actually a lot simpler than it sounds.
Okay.
It basically says that the more concurrent tasks you have,
Yeah.
those cars on our highway,
Right.
the higher the throughput.
Okay.
More things getting done faster.
Makes sense.
But the old way of handling threads, it created a bottleneck,
Okay.
limiting how many cars could be on the highway at once.
Okay, so we're at a standstill.
Yes,
What did developers do?
right.
Because we all know apps didn't just stop working.
No, they're clever, these developers.
Yeah.
They found ways around it, coming up with asynchronous programming.
All right, break that down for us. What's the workaround?
Instead of each car getting its own lane, now we're talking about a system where each car only needs the lane when it's actively moving.
Okay.
The rest of the time, it's pulled over, making room for others.
Okay, so more efficient use of the highway. But
Yeah.
there's always a bug, isn't there?
You got it. Asynchronous programming is powerful,
Mm-hmm.
but it can be a real headache to work with.
Okay.
It's like trying to track the movement of all those cars when they're constantly stopping and starting, switching lanes and disappearing and reappearing.
Yeah.
And this is where observability comes in.
This is something Pressler kept coming back to.
Yes.
Why is observability so important in this context?
Imagine trying to debug a problem in this chaotic traffic system.
Yeah. Yeah.
Good luck figuring out why one car is stuck or where the bottleneck is.
Right.
Asynchronous programming made it much harder to track the flow of execution, which is crucial for finding and fixing bugs.
So asynchronous programming was like finding a side street
Yeah.
to bypass the traffic jam, but it came with its own set of challenges.
Precisely. It was a workaround, a clever hack,
Right.
but not a true solution.
Okay.
And this is where other programming languages took a different approach.
Yeah.
They started incorporating features like async await,
Mm-hmm.
which gave you some of the benefits of asynchronous programming
Okay.
without all the complexity of threads.
Makes sense.
Yeah.
So why didn't Java just follow suit?
Well,
Pressler seemed a little coy about this in his presentation.
Java's designers had to consider its enormous existing code base.
Right.
Any change to how concurrency is handled could potentially break millions of lines of code.
Wow.
It's not just about adding a new feature.
Yeah.
It's about ensuring that the foundation remains stable.
Right.
That's where the deep technical difference between threads and these new async await constructs comes into play.
I'm sensing this is where we get into those nuances you mentioned earlier. What's the core difference?
It all boils down to how and when tasks are scheduled to run.
Okay.
Think of it like this. Threads are like jazz musicians. They can jump in at any point, improvise,
Right.
and create a dynamic performance.
Yeah.
This flexibility is powerful, but can be unpredictable.
Okay.
Async await is more like an orchestra.
Oh,
Each instrument has its designated part,
right.
and they follow a strict conductor.
Right.
It's predictable,
Mm-hmm.
but it doesn't allow for the same kind of dynamic improvisation.
So why wouldn't Java just go with the well-conducted orchestra?
Remember all that existing Java code?
Yeah.
A lot of it relies on the jazz improvisation of threads.
Okay.
Changing that would require massive rewrites and potentially break a lot of things.
Oh, the dreaded legacy code rears its head.
Exactly.
I'm starting to understand why Java had to take a different route.
This is where Java's control over its virtual machine, or JVM, gave them a unique advantage.
Okay.
Think of the JVM as the stage where the jazz musicians, the threads, perform.
Okay.
Java's designers realized they could change the stage itself,
Okay.
creating a system where it looked like there were tons of musicians, even though there weren't.
Oh, okay.
This is the essence of virtual threads.
So it's like having a hologram projector that makes it seem like we've got a whole orchestra on stage, when in reality, it's just a really clever illusion.
Exactly.
Okay.
But here's the beauty of it.
Yeah.
From the audience's perspective, the music sounds just as good.
Right.
And for Java developers, their existing code,
Yeah.
written for those improvising jazz threads, would often work seamlessly with these new virtual threads.
Wow.
No need to rewrite the whole performance.
This is starting to feel like that virtual memory magic trick.
Yes,
But for concurrency,
exactly.
you've got a limited resource, physical threads, and virtual threads make it seem like they're practically infinite.
Exactly.
Wow.
And this is where things get really interesting.
Okay.
Because with this new abundance of virtual threads,
Yeah.
some old habits die hard.
Oh. Tell me more about these hard-to-break habits.
Developers had spent years optimizing for a world with limited threads.
Right.
One prime example is the use of thread pools.
Okay.
Imagine a restaurant holding on to a large pool of waiters,
Okay.
even when it's not busy, just in case a huge dinner rush hits.
Because hiring and training new waiters on the fly would be too slow?
Precisely.
Okay.
But with virtual threads, it's like having a magical bell that summons a perfectly trained waiter instantly whenever a new customer arrives.
So holding on to that pool of waiters is no longer efficient.
Right.
Even desirable.
Yeah.
You're adding unnecessary overhead in a world where resources are now abundant.
Exactly.
Wow.
That's the aha moment.
Okay.
With virtual threads, you don't need to hoard and manage these resources so carefully.
Right.
You can create a virtual thread for each customer, each task, knowing they're lightweight and won't bog down the system.
That's such a fundamentally different way of thinking about concurrency.
It is.
It's not just about optimization anymore.
No.
It's about freeing yourself from those old constraints. It's like we've discovered a new continent, computing power,
right?
and now we get to like explore it.
And with exploration comes new tools.
Okay.
Remember those other innovations Pressler highlighted?
Yeah.
Things like ZGC and JDK Flight Recorder?
Okay.
They might seem unrelated, but they actually play a crucial role
Okay.
in this new virtual thread landscape.
Okay. Connect the dots for us.
Yeah.
How do they fit into the picture?
Think about it.
Okay.
If we're moving towards a world where we can spin up virtual threads with ease,
Yeah.
we need a way to manage the resources they use.
Okay.
That's where ZGC comes in.
Okay.
It's like having a super efficient cleanup crew that instantly removes any garbage created by those threads, unused memory.
Right.
This keeps the system running smoothly no matter how many virtual threads you're juggling.
So it's not just about having like a million cooks in the kitchen.
Right.
It's about making sure the kitchen stays clean and organized, even with all that activity.
Precisely.
Okay.
And then there's JDK Flight Recorder,
Okay.
or JFR. If ZGC keeps things tidy,
Yeah.
JFR is like having a detailed log of every action,
Okay.
every ingredient used, every dish prepared
Okay.
in our virtual kitchen.
Okay.
It gives developers incredible insight
Yeah.
into how their code is performing down to the individual virtual thread.
Which is crucial for understanding how these virtual threads are behaving in the real world, right?
Oh, yeah.
Because even with this elegant solution, there are bound to be like unexpected hiccups.
Absolutely.
Right.
JFR allows developers to spot bottlenecks,
Okay.
optimize performance, and track down those elusive bugs that inevitably pop up in complex systems.
It seems like Java is going all in on not just making concurrency easier, but making the entire development process more efficient and transparent.
It's about giving developers the tools they need to fully embrace this new era of concurrency.
Yeah.
Because when the limitations of the past disappear, what emerges is a whole new world of possibilities.
Right.
Pressler asks this very question.
Yeah.
What happens when those limits no longer constrain us?
Yeah.
What incredible new applications and services will we see?
It's almost like we've moved past just like optimizing code to actually rethinking what's possible in software.
Yeah.
If virtual threads deliver on their promise, we could see a wave of innovation that was previously unthinkable.
It's an exciting time to be a developer.
Yeah.
Or just someone who uses software.
Right.
This shift in how we think about concurrency has the potential to reshape the entire technological landscape.
So the next time you're amazed by an app that seems to handle a million things at once,
Yes.
remember those virtual threads working tirelessly behind the scenes?
There they are.
And if you're a developer working with Java,
Yeah.
well, this is your call to action.
Yes.
Dive into this new world of virtual threads.
Explorement.
Experiment.
You can live for it.
Explore, and who knows?
Right.
You might just create the next game-changing application.
Because when the boundaries of the possible expand, the only limit is our own imagination.
And on that note,
Yes.
we'll leave you with this final thought.
Okay.
In a world no longer bound by the limitations of old, what will you build?
I like it.
What new possibilities will you unlock?
Keep exploring, keep innovating,
Yeah.
and keep diving deep.
We'll be here to guide you through it.